We have an example problem here. Determine the force on your fingertip due to a 100-watt bulb, meaning a light bulb. So determine the force on your fingertip due to a 100-watt bulb, a distance of 8 centimeters away. Assume the surface area of your fingertip is 1 centimeter squared, and that your fingertip completely absorbs the light. Now, our fingertips do not completely absorb the light, but the reason we're making that assumption is because that is the equation that our author has chosen to give us. So again, radiation pressure. We have this line in our test notes with these equations. So I is the intensity. We'll need to find the intensity of the light where our finger is placed. That comes from knowing the power of the light bulb and the area the light spreads over or covers. This intensity has nothing to do with our fingertip. Our fingertip is not emitting the energy. It's going to absorb energy, which that takes us back to the radiation pressure. Now, we're going to get a ridiculously small number, by the way. I'm sure you have probably can recognize that you have not been pushed around by lights. So these forces are not anything that we notice. I'm going to go ahead and find this intensity separately and then bring it back and put it into our radiation pressure equation. I know the intensity of the light bulb. They tell us the power is 100 watts. Now that's not specifically stated as power, but 100 watts, I do need to recognize that watts is the correct unit for power. And I know a light bulb emits light in all directions equally, well, mostly equally. The base, of course, blocks some of it. So intensity will be power divided by a spherical surface area. R is the radius of the circle or sphere. The light bulb is the center, is the source. So when we talk R here, R is the distance from the source to wherever we want to know the intensity. So we're going to hold our finger 8 centimeters away from the light bulb. So 0.08 meters. This is going to give me the intensity of the light 8 centimeters away from this light bulb. So 1.2434 times 10 to the third watts per meter squared. Okay, this intensity is the intensity in our radiation pressure equation. We're trying to find the force on our fingertip. So the force is because of radiation pressure. So the force our fingertip would experience divided by the area of our fingertip has to equal this intensity that we've calculated divided by the speed of light. Now they've given us the area of our fingertip, but they've done so in centimeters squared. As a reminder, we do know there's 100 centimeters in a meter, but when we're converting the centimeters squared, we have to square the whole conversion. So the area of our fingertip will be 1 times 10 to the negative 4 meters squared. Coming back to our equation, the force our fingertip experiences that we can't actually feel would be this intensity we calculated over the speed of light times this area in meters squared. So 4.1 times 10 to the negative 10th. This will be in newtons. If you want to follow the units through, intensity is watts per meter squared. And then we're multiplying it by an area, which is in meters squared. And C is the speed of light. A watt, though, is a joule per second, which we're dividing by meters per second, so the seconds cancel. So we have joules per meter. A joule is a newton times a meter. When we divide by meters, we're getting the newtons. So I'm just making sure I get everything into my SI units. That's my best chance of getting the correct units on my answer, for me anyway, is to make sure my units are correct going in.